Hello viewers, this is Ronald taking you through the tutorial for A-Level Applied Mathematics. And this video, we're going to talk about a topic of discrete random variables. So this topic is under probability and is suitable for students in both Senior 5 and Senior 6, offering principal mathematics as part of their combination. So a discrete random variable is a variable that assumes specific values within a given interval, and the possibility space for a discrete random variable is defined over a countably finite or countably infinite sample space. Examples of discrete random variables include number of houses in a given location, number of people in a given geographical area, this is area, number of mature trees in a given acreage of forests, and etc. Now this topic can be subdivided into three parts. Now the first part is discrete PDF or probability distribution functions. The second part is discrete cumulative discrete distribution functions or CDF, and the last part is discrete uniform distribution functions. So all these three parts will be looked at in this video. Now we shall start with the first part of discrete probability distribution. So a discrete probability distribution function is a function whose random variable, say x, takes on specific, know this word, specific values of x, like 1, 2, 3, 4, like that. As you can see it here in an example, this is an example of a discrete PDF. So it takes on values, discrete values, 1, 2, 3, 4, 5, etc. So it doesn't take on decimal points, it not only takes on whole numbers. Now this 0 elsewhere means that outside these values of x, the probability is 0. And these values of x, if we want to get their corresponding probability, it depends on this function here. So when I put x1 here, it means that I can get the probability for x equal to 1. When I put 2 here, I can get the probability for x equal to 2. When I put 3 here, I can get the probability of x equal to 3. When I put the probability 4 here, I can get the probability of x equal to 4. And when I put 5, I can get the probability of x equal to 5. But when I put other values outside this range, for example, when I want to get the probability of x equal to 6, that 6 goes here for elsewhere. So elsewhere caters for all other values which are not in this part. That is why you said that the possibility space can take on a countably infinite possibility space, because here I can put any other value, but to be catered for in this part of elsewhere, and this probability will be 0. So we shall also talk about individual probabilities. So individual probabilities, this involves substituting directly the values of the random variable into the function for a given domain. I think we have answered that in the previous slide. When I put x equal to 1 in the function, I'll come up with 1 over 15. When I put x equal to 2, the probability is 2 over 15. X equal to 3, the probability is 3 over 15. Because now this is the function we are interested in. X equal to 4, I'll come up with 4 over 15. X equal to 5, I'll come up with 5 over 15. So these are the individual probabilities for the function expressed in the above slide, which is this very function. Now we are stopping at 5 because when you look at this, the ranges which we have varied were from x equal to 1 up to x equal to 5. So that is why we started from 1 and ended at 5. So now we shall go to discrete probability. These are all definitions under discrete PDF. So the third definition is discrete probability distribution table. So they can either put this word table or they may not put it. As long as they say discrete probability distribution, just know that they mean a table. So this is a table listing all possible values that a random variable can take along the associated probability. So this table contains variable x and also its corresponding probability. So when x equal to 1, the corresponding probability is put there, 2, the corresponding probability is put there, 3, the corresponding probability, 4, corresponding probability, and 5, corresponding probability. So when you tabulate these values of x and their respective probabilities, what comes out is called a probability distribution or probability distribution table. So they may either put this word table or they don't put it there. Then we shall now go to the discrete probability distribution graph. Now the graph of a PDF, discrete PDF specific, remember there is continuous PDF and discrete PDF. So in this video we're talking about discrete PDF. Now continuous PDF will be talked about under continuous random variables. So the probability distribution graph for a discrete random variable x is a graph of px equal to x against x. So px equal to x is put on the vertical axis and this x is put on the horizontal axis, comprising of vertical lines. Know that word, vertical lines, drawn from specific values of x corresponding to their respective probabilities. So remember the probability of x equal to 1 was 1 over 15, therefore you draw a vertical line at 1 up to 1 over 15. The one of x equal to 2 was 2 over 15, so you draw a vertical line up to 2 over 15. The one of x equal to 3 was 3 over 15, so you draw a vertical line up to 3 over 15. The one of 4 was 4 over 15, so you draw a vertical line up to 4 over 15. And the one of x equal to 5 was 5 over 15, so you draw a vertical line up to 5 over 15. So basically that's how they draw graphs of discrete PDF. Now the note is that the mod of x is the value of x corresponding to the highest probability. For in this case the highest probability is this, therefore the value of x corresponding to that probability is 5. Therefore if they ask for mod of this PDF, it will be 5. So after drawing the graph you can easily state the mod of that PDF. So now we shall go to the other part E, which is total probability. Now this is where you need to be as more attentive as possible from this part onwards. So total probability is always equal to 1. I believe you remember that under probability theory. So in this case that means that summation of all x of their probabilities must be equal to 1. So that is how they express the total probability mathematically. So this summation of px means total probability because there is this word all x, so it will be equal to 1. Therefore when you see this symbol, just know that they want you to add up all the probabilities and equate them to 1. And this formula is used to get the unknown value. So usually in the PDF they will give you an unknown constant in it, and when they tell you to get the unknown constant, always remember that total probability is equal to 1. So another parameter is mean or expected value. So mean, another word for mean is called expected value of x, and this value is denoted by ex. So when you see ex, just know that they mean expected value, and the formula used is this. Now these formulas are also available in your mathematical tables, and I hope you already have one of them, because as long as you're in A-level you really need a mathematical table to save you from memorizing some of these formulas, since they are already listed there and they allow you to go with them in the examination room. So ex is what is got by summing up the value of x multiplied by its corresponding probability for all values of x. We shall see how to use that formula. So what we need to note is that expected value of a constant is equal to that very constant. But if there is a variable, for example ax, it means that the expected value will be equal to this constant multiplied by the expected value of x. Then if it is a linear equation still, ax plus b, it implies that this b comes out because the expected value is that very constant. Then for this part, like we have seen here above, it will be a multiplied by ex. What if it is a quadratic? What if it's a quadratic? It means that for this part it will be a multiplied by ex squared. For this part it will be b multiplied by ex squared, and this part it will only be c. So these ones will be used frequently. So a, b, and c are constants. It can be 1, 2, 3, 4, and so on. The another parameter is called variance of x. Now variance of x is denoted by var x and is given by the formula ex squared minus ex everything squared. Now I think you realize that here the box brackets, there is a box bracket here before the square. What does that mean? It means that you first get ex, which is the expected value of x. After that you square what you have got to get the whole of this. So that box bracket is very, very vital. Here it is only ex squared. We have not yet seen the formula for ex squared, and this formula is here. So I think you realize that there is some similarity between ex and the formula. If here there is x squared, it implies that the probability will be multiplied by x squared. If there is only x, it implies that the probability will be multiplied by x, as we saw in the previous slide. So that is one of the simpler way to memorize the formula. So here we need to know that now, unlike expected value, when it comes to variance, the variance of a constant is 0. So what does that mean? It means that the variance of ax is equal to s squared multiplied by variance of x, and the variance of ax plus b, it implies that it is s squared multiplied by variance of x. Now here we don't say plus b. Why? Because we already saw that the variance of a constant is 0, where a and b are constants. Then lastly, we have what we call standard deviation. Standard deviation is the square root of variance. So if this is the variance, you get a square root, that will be the standard deviation. So these formulas are very vital and you have to know how to use them. So let's see how they can be used. So we shall start with question 1, which came from UNEB 2019, paper 2, question 4. And it says that a discrete random variable x has the following probability distribution. So this is the values of x, and these are their corresponding probabilities. But you realize that there is an unknown constant in this, and here they said find the value of p, which is a constant. Then part b, find the expected value of x. So what you should remember is that as long as they ask for an unknown constant, you must remember the concept that we use the formula of total probabilities. So for part A, we shall come and say that total probability is equal to 1. Then what we are going to do, we are going to list all these probabilities, add them and equate them to 1. So when you do that, we shall come up with that. And now the next thing to do is to make p the subject, and that is the value of p. Then for part B, they wanted the expected value of x, so that is mean, and mean is given by the formula xpx. Like I told you, when here there is x, it implies that the probability is multiplied by only x. So you come here and multiply the values of x with their corresponding probabilities. When x is 0, probability is that. When x is 1, probability is that, when x is 2, probability is that, when x is 3, probability is that, when x is 4, probability is that, because you have got the p is equal to 0.3, and when x is 5, p is that. Now when I use the calculator, I'll come up with what they want, and that will be my mean or expected value of x. So basically that's what they wanted. Now let's see how much can be awarded. M1 for this addition and equating to 1, and A1 for the value of p. M1 for all these multiplications, multiplying p with their corresponding multiplying x with their corresponding probability, and another M1 for adding all those outcomes. Then A1 for the value of mean. So that was question 1. Now we shall go to question 2, which came from UNEB 2007 paper 2, question 9, and it says a discrete random variable x has a probability distribution given by this, where k is a constant. Then say determine Roman 1 the value of k, Roman 2 the probability of x greater than 2 but less than 5. Then part C expectation ex, and part D variance, which is noted as var x. So here the first part of k, we should remember that we add up all the probabilities and equate them to 1. So how do you get the probabilities? We get them from the formula which is given. For example, probability of x equal to 1 will be got by putting 1 here, x equal to 2 will be got by putting 2 here, x equal to 3 will be got by putting 3 here, x equal to 4 will be got by putting 4 here, x equal to 5 will be got by putting 5 here. Now what we get, we shall add all of it and equate it to 1. After that we shall make k the subject, and that will be the answer they want. So let's do that. So we shall come here and say that whenever they want unknown constant, you should remember that total probability is equal to 1. So we are going to add up all those probabilities and equate them to 1. Then we make k the subject. So this is the value of k they wanted. Then part B, they wanted the probability of x greater than 2 but less than 5. So the values of x which are greater than 2 but less than 5 are these ones. So greater than 2 means that 2 is not required, so 3 is required, 4 is required, but they told us less than 5, so 5 is not required. So these are the two values which are required. We are going to get their corresponding probabilities and add them. So you come here and say that probability is equal to probability of x equal to 3 plus x equal to 4. Then we substitute for those probabilities, which is that. Then when we add the 2, we shall come up with 7 over 15. You can either stop here or you round off to 4 decimal places. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for the individual probability is getting all these probabilities from the given formula. Then this one is for adding them and equating them to 1. This A1 is for the value of k. M1 is for this substitution, both and addition, and A1 is for the output. So now we shall go to part C, where they want the expectation of x, and part D, where they want the variance of x. So you have to be remembering the formula for expectation of x and variance of x. So ex is given by x multiplied by probability of x. So all the values will be multiplied: 1 with its corresponding probability, 2 with its corresponding probability, 3 with its corresponding probability, 4 with its corresponding probability, 5 with its corresponding probability. So when I add all these ones, I'll come up with 11 over 3. And that will be the expected value of x. Now part D, they wanted the variance, but for you to get the variance, you have to first get the ex squared. So ex squared, like I said, what is here is what is multiplied by the probability. So I'll come and multiply 1 squared with its corresponding probability, 2 squared with its corresponding probability, 3 squared with its corresponding probability, 4 squared and corresponding probability, 5 squared and corresponding probability. Now when I add all these ones, I'll come up with 225 over 15, but that is not the answer they want. After that, you should remember that the variance is given by ex squared minus ex everything squared. So I'll come and put this one here, then I remember that ex was 55 over 15, which is there, and I square it. When I do that, the outcome will be 14 over 9, and that's what they wanted. So M1 is for all these multiplications, multiplying the value of x with this corresponding probability, and M1 is for all adding all the outcomes. Then A1 is for the output. For this part, M1 is for all these substitutions, and B1 is for the output. Then M1 is for this substitution, and A1 is for the output. So that was question 2. Now we shall go to question 3, which came from UNEB 2006 paper 2 question 7, and says the probability distribution for the number of heads that show up when a coin is tossed 3 times is given by this function 1 over k. Now this symbol usually disturbs students. So why? Because some students think this is the symbol for vectors, but this is not a symbol for vectors. As long as it's under PDF, you always remember that this symbol means combination. So I can either choose to write 3 combination x, or I write it in column form. So this is the one which is commonly known by students, but when you have a mathematical logbook, you realize that this symbol is also valid. So to get the probability of x equal to 0, put 0 here. Probability of x equal to 1, put 1 here. X equal to 2, put 2 here. X equal to 3, put 3 there. So part A, they said find the value of k, and part B, find the expected value of x. So value of k, you should remember that total probability is equal to 1. Therefore, we shall come and code the formula, then substitute. X equal to 0, put 0 here. X equal to 1, put 1 here. X equal to 2, put 2 here. X equal to 3, put 3 here. Then from there, remember that 3 combination 0 is 1, 3 combination 1 is 3, 3 combination 2 is 3, and 3 combination 3 is 1. Therefore, add all those probabilities and equate them to 1. Then make k the subject. So that's what they wanted. Now let's see how much can be awarded. So M1 for getting all these individual probabilities. Then another M1 for adding all of them and also equating them to 1. And A1 is for the value of k. So part B, they want EX. So EX is given by that formula, so we are going to multiply x with its corresponding probability. 0 times the probability, 1 times this probability, 2 times the probability, 3 times the probability. Then when you use the calculator, we shall come up with 1.5 as the answer. So basically that's what they wanted. M1 for this substitution and A1 for the output. That was question 3. Now we shall go to question 4, which came from UNEB 2012 paper 2 question 8, and says a random variable x has the following probability distribution. Probability of x equal to 0 is 1 over 8, x equal to 1 is equal to x equal to 2 and is equal to 3 over 8. Then the probability of x equal to 3 is 1 over 8. Find Roman 1 the mean of x and Roman 2 the variance of x. So for mean, we know that this is given by this formula. When there is x here, I put x there. So we're going to substitute x with its corresponding probability up to the end. They will stop at x equal to 3, so the outcome is 3 over 2, and that will be our mean of x. For variance, we have to first get ex squared, which is given by that. So where here there's x squared, you also put x squared and multiply by the probabilities. So when we do that, we shall come up with these values and add all of them to come up with 3 as ex squared. But this is not the variance they want. After getting this, you have to remember that variance is given by the formula ex squared minus ex everything squared. So ex squared is this, and ex is 3 over 2, which is that, but it is squared, so you put a squared there. And the outcome will be 0.75, and that is what they wanted. So M1 for all these substitutions, A1 for the output, B1 for getting ex squared, and M1 for substitution, A1 for the output. So that was question 4. Now we shall go to question 5, which came from UNEB 1993, paper 2, question 10b, and it says the number of times a machine breaks down every month is a discrete random variable x with a probability distribution given by this. So I think what you should realize first is that here we don't have any end value. What does that mean? It means that the values range up to infinity, where k is a constant. So determine the probability that the machine will break down not more than 2 times a month. So we have this formula, and we have the values of x ranging up to infinity. That is what you should first note. So here, to get the unknown constant, you should remember that total probability is equal to 1. So we are going to add up all the probabilities and equate them to 1. What you should remember is that there are these 3 dots to mean that the values are still continuing up to infinity. Now when you see that, it implies that this is either a GP series or an AP series. If you look at this, because there is a common ratio, how do you know that there's a common ratio? When you say this divide by this, you get a quarter. This divide by this, you get a quarter. This divide by this, you get a quarter. So that means that there's a common ratio. So this is a GP with a common ratio with the first term as this and common ratio as a quarter. Therefore, what we are going to use, because the series is up to infinity, we use the formula for sum to infinity, and the formula for sum to infinity is a over 1 minus r. I think you remember that under series in math 1. Now this case still there because it was outside the bracket. We are equating to 1 because of that 1. So what you're going to do, we are going to substitute for a and r, and we remain with k as the only unknown. Therefore, when I simplify, I come up with this, and therefore the value of k is 3 over 4. But they wanted the probability of not more than 2. That means x is less than or equal to 2, meaning that the values are 2. If we go back to this, so less than or equal to 2 means that we want this, we want this, we want this, but from this onwards is not needed. So you get the probability for x equal to 0, x equal to 1, and x equal to 2. So when I substitute x equal to 0, x equal to 1, and x equal to 2, so the outcome will be this, and the answer will be 63 over 64. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for this substitution and equating to 1, M1 for substitution into sum to infinity, and B1 for the value of k, M1 for this substitution, A1 for the output. So that was question 5. Now we shall go to question 6. Question 6 says a discrete random variable x has a probability distribution function given by this. If ex is equal to 3, find the value of k and n. So I think you realize that in this distribution there are some values here which we don't know, but they stop at n, and we also don't know the value of n. So in this case they have given us two unknowns. There is this and there is also this. That means that you have to get two equations. One will be got from this one of Ex equal to 3, another will be got from the one we already know, that total probability is equal to 1. So when you start with the one of total probability equal to 1, we are going to add up all those values. I think you realize that we are putting some dots here. You should know these dots are very vital because there are some values here which we don't know. Then we shall equate to 1 and come up with a series. And that series, I think you remember in under math 1, you talked about standard series. Now the standard series of 1, 2, 3 up to n is given by the formula a half n multiplied by n plus 1. So this is the standard series. I believe you already covered it in math paper 1. So 2, we shall come up with Ex equal to 3. Now Ex is equal to x px. Therefore it's equal to 3. Now I'm going to substitute x multiplied by its corresponding probability to come up with this. Then k is a constant, factorize it outside and cross multiply. So I'll bring this k this side to come up with 3k. Now this is also a standard series, and this formula is 1 over 6n in brackets n plus 1 multiplied by 2n plus 1. So these are standard series. So before we go to the next slide, we shall get marks for this slide: B1 for equation 1, another B1 for equation 2. So now we shall solve. Those are two equations and two unknowns. We have to solve them simultaneously. What I'm going to do, I'm going to substitute 1 into 2 to come up with that. Therefore now I have only one unknown. I have to simplify and get that value. So I'll bring this one this side to come up with this. Then you realize that there's a common factor. N is common and n plus 1 is common. So I'm going to factorize them outside to remain with 2n plus 1 here and 9 here. So that means that I'll get 3 factors, and that implies that either n is equal to 0 or n is equal to -1 or n is equal to 4. But n cannot be 0 and n cannot be equal to -1 because these are countable. Remember, when you looked at this series, it was counting from 1, 2, 3, 4 up to n, meaning that n is greater than 1, is greater than 0, and is also greater than -1, so it should be 4. Therefore we shall come and conclude that n is equal to 4. Now we have got one value, so we shall go back from equation 1 and substitute for n. Then we come up with the value of k. Remember, the k was equal to a half n multiplied by n plus 1. So n plus 1 gives you 5. So when you simplify this, I come up with 10, and that will be the value of k which they wanted. So M1 for this substitution, M1 for this factorizing, A1 for the value of n, M1 for this substitution, A1 for factorizing. So that was question 6. Now we shall go to question 7, which came from UNEB 1996 paper 2, question 5, and it says a balanced coin is tossed 3 times, note this word balanced, and the number of times X a head appears is recorded. Complete the following table. Then they said determine the average of the expected number of heads to appear. That is mean. So here probability of x equal to n means that you count this 1, 2, 3. When you look at this, it implies that the total sum possibility space is 8. Therefore these are 3, 1, 2, 3. Therefore the probability will be 3 over 8. For this one too, the events can be head, head, tail, or because they want 2 heads, then another one can be head, tail, head, another one can be tail, head, head. So there are also 3. Therefore the probability will be 3 over 8. For this one, it is only 1 because you can only get 3 heads once. Therefore, the probability is 1/8. Then they also wanted you to get the mean or the average. So if you remember that the mean is given by xpx, therefore come and multiply this with this to come up with this, this with this to come up with that, this with this to come up with this, this with this to come up with that. When I add all these ones, I come up with 3/2, and that's the mean they wanted. So B1 for filling in these events and another B1 for filling in these probabilities. Then M1 for these multiplications for each value of x, and another M1 for adding up all those outcomes, and A1 for the output. So that was question 7. Now we shall go to question 8, which came from UNEB 2020, that is last year, paper 2, question 15, and it says a certain football team has 3 matches to play. The probabilities of winning first, second, and third matches are 3/4 for the first, 2/5 for the second, and 1/5 for the third. That is why there is this word respectively. Then part A, find the probability that the team wins Roman 1 exactly 2 matches, Roman 2 all the 3 matches, Roman 3 no match. And part B, if a random variable x is defined as the number of matches won, Roman 1 construct a probability distribution table for x, and Roman 2 calculate the expected value of x, which is denoted as ex. So you start with part A. So the probability of winning exactly 2, it means that in the first you win first and second and you lose third, or win first and third you lose second, or win second and third you lose first. Therefore, when I substitute, we are given this is for winning first, winning second, and losing third. Losing is the complement of winning, so 1 minus 1/5, you get 4/5. Then for the second one, this is winning first, losing second, and winning third. Then this is losing first, winning second, and winning third. So when I add all those ones, I'll come up with 37/125. Roman 2, they wanted the probability of winning all the matches, so you win first, second, and third. So that is first, second, third. Therefore the outcome was 6/125, and that's what they wanted. So M1 for these multiplications and addition, multiplying all these ones, so this, and this, that is M1. Then this one is adding all the 3, and this is for the output. This one is for these substitutions, and this is for the output. Roman 3, they wanted the probability of winning no match. So winning no match is x equal to 0, which is lose, lose, lose. Therefore this is losing first, losing second, losing third, to come up with 24/125. Now here they told us if a random variable x is defined as the number of matches won, Roman 1 construct a probability distribution table for x, and Roman 2 calculate the expectation of x. So remember, the probability distribution table is a table containing x values and their corresponding probability. So we don't know yet the probability of x equal to 1, so we have to get it that is the complement of the rest. So the rest are these ones, the ones I've got. This is x equal to 0, x equal to 2, x equal to 3. Therefore, when I add all those ones and I say 1 minus those ones, I'll be able to get the probability of x equal to 1, which is the remaining one. Now that I have probability of x equal to 0, x equal to 1, x equal to 2, and x equal to 3, I can come and draw my probability distribution table. So x, probability of x. So the first one is x equal to 0, the probability is 24 over 125. The second one is x equal to 1, and the probability is 58 over 125. Then the previous slide we saw the probability of x equal to 2, and it was 37 over 125. We also saw the probability of x equal to 3, and it was 6 over 125. So basically that is the probability distribution table they wanted. Now we shall go to part B. Part B, we know that this we multiply x with the corresponding probability. This with this gives me that, this with this gives me that, this with this gives me that, and this with this gives me that. So when I add all these ones, I'll come up with 1.2 as my answer. So M1 is for this, A1 is for this output, B1 is for this probability, this B1 is for tabulating all those values, then M1 is for multiplying these multiplications, then another M1 is for adding up all the outputs, then A1 is for the final answer. So that was question 8. Now we shall go to question 10, which came from UNEB 2018, paper 2, question 15, and it says that the table below shows the number of red and green balls put in 3 identical boxes A, B, and C. So this is box A, we put 4 red and 2 green. In box B we put 6 red and 7 green. In box C we put 3 red and 5 green. A box is chosen at random and 2 balls are then drawn from it successively without replacement. If the random variable x is defined is the number of green balls drawn, part A, draw a probability distribution table for x, and part B, calculate the mean and variance of x. So we are going to first get the probabilities of x equal to 0, 1, and 2. So x equal to 0, it means that you pick no green from A, you also pick no green from B and no green from C. So that means that when we use combination, because it was without replacement, you can use either combinations or a tree diagram. So let's choose the one for combination. So no green, it means that when you'll come at A, remember in A there was 4 red and 2 green, so the total is 6. Therefore no green means that 2 combination 0 multiplied by 4 combination 2, because they are picking 2 balls. So that means that all the 2 were picked were red, therefore it will be 4 combination 2. That is why you see here 2 combination 0 multiplied by 4 combination 2 over 6 combination 2. 6 is the total, 2 plus 4 is 6. But remember, you first pick a bag, therefore picking A is 1 over 3 because there were 3 bags, A, B, and C. Then when I pick B, it will be a third, then the picking 2 balls, but I'm picking no green, it means that I'll pick 2 from red, 2 which will be red, therefore to be 7 combination 0 multiplied by 6 combination 2, and remembering the a third. So 7 combination 0, 6 combination 2, then you will put the total. 7 plus 6 is 13, that is why you see here 13 combination 2. Then picking box C is a third, then picking no green, it means that it will be 5 combination 0 multiplied by 3 combination 2. That is why you see here 5 combination 0, 3 combination 2 over 8 combination 2. This 8 is the total, which is 5 plus 3. Therefore, now as a calculator, 2 combination 0 is 1, 4 combination 2 is 6, 6 combination 2 is 15, 7 combination 0 is 1, 6 combination 2 is 15, 13 combination 2 is 78. 5 combination 0 is 1, 3 combination 2 is 3, 8 combination 2 is 28. So when I simplify all this, I'll come up with 1273 over 5460. Then for x equal to 1, it means that you pick 1 green from A and 1 green from B and 1 green from C. Therefore, it means that here, instead of putting 0, I'll be putting 1 green and 1 from here. Then here 1 green and 1 from here. 1 green and 1 from here. The rest remains the same. Next, I'll use a calculator to come up with that, and the answer will be 8777 over 16380. So that is for x equal to 0 and x equal to 1. We also have to get x equal to 2, but before we do that, let's see marks for this. So M1 for this substitution, A1 for the out, B1 for output, M1 for this, B1 for output. Then x equal to 2, it means that it's a complement. So complement is 1 minus these two outcomes. So 1 minus that, I come up with 946 over 4095. So now that I've got x equal to 0, x equal to 1, and x equal to 2, I can come and draw my probability distribution table. So x and corresponding probability. So x equal to 0, the probability was that. Then x equal to 1, the probability was that. Then x equal to 2, the probability was that. So that's what they wanted. Part B, they wanted the expectation of x. So expectation is x, probability of x equal to x. So I'm up this by this gives me that, this by this gives me that, this by this gives me that. When I add all those ones, I'll come up with 467 over 468 as my expected value. So basically that's what they wanted. Now let's see how marks can be awarded. So B1 for this probability, B1 for tabulating all the probabilities, M1 for the substitution, A1 for the output. So they also wanted, if you look at the question, they wanted mean and variance. So we have got mean, we have not yet got variance. So let's go and get the variance. So before you get variance, you have to first get EX squared. So EX squared is that, and gives you 2657 over 1820. Then after getting EX squared, you can get your variance from EX squared minus EX, everything squared, to come up with this as this, and this was got in the previous slide. So you come up with 0.4642 as your variance. So M1 will be for the substitution, B1 for the output, M1 for the substitution, B1 for the output. So that was discrete PDF. Now we shall go to the second part, which is discrete CDF, or discrete cumulative distribution function. A discrete CDF is a function of probability of x equal to x and is denoted as this. So is a cumulative distribution function of this and is denoted by probability of x less or equal to x, and that is defined by x by this expression. So you keep on adding, just like we used to get cumulative frequency under elementary statistics. You keep on adding the frequencies. Now also here, to get cumulative PDF, you keep on adding the probabilities. Therefore, if x has a probability distribution function given by this, we can easily get the CDF from these probabilities, as we shall see in the next slide. So when I choose to draw a tabulated values, these are the values of x from the function in the previous slide, and these are the corresponding probabilities. Therefore, to get the CDF, like I said, use the method similar to that of cumulative frequency. So cumulative PDF will be, first write this probability here, then after that I say this plus this, it gives you this, this plus this gives you this, this plus this gives you this, and this plus this gives you that. So these are tabulated values, but you can also draw you can also use a express in terms of a formula where you say probability of x less than. Now note the inequality. This inequality means it is no longer a PDF, it is now a CDF. So for x less than 1 is 0, then x between from 1, x greater than 1 but less than 2 is that, which is that, then this is that, the next is that, next is that, and next is that. So we put 1 because 15 over 15 is 1. So we can either express the CDF by tabulating or by using the formula. Now just like we saw how to draw a discrete probability distribution graph, here we should also see how to draw a discrete cumulative distribution graph. Now, unlike the one for a probability distribution graph, for a cumulative discrete distribution graph of a discrete random variable x, the graph comprises of horizontal lines. Remember, for discrete PDF probability distribution graph, it was represented by vertical lines, but these ones are horizontal lines drawn from specific values of x towards the next values corresponding to their respective cumulative probabilities. So what do I mean? If I have the x-axis like that, so I'll go back and say that for this interval it was 1 over 15. So I think you see it starts from 1, but it does not reach 2. It is just less than 2. So it means that I'll come and look for my 1.5 and look for my 1 and draw that horizontal line from 1 onwards. It goes towards 2, but it doesn't. When it reaches 2, it jumps. So when it reaches 2, for x greater than or equal to 2, it jumps to 3 over 15, and this 3 over 15 goes but doesn't reach 3, it goes towards 3. So what does that mean? It means that when I come here at 3 over 15, it will jump to this. So I think you'll see that it from 1 up towards 2, it was 1 over 15. When it reached 2, it jumped to 3 over 15. Then also when it reaches 3, it is going to jump. For example, when it reaches 3, it is going to go to 6 over 15. So come here and draw 6 over 15. Like that. Then when this one goes towards 4, but when it reaches 4, it is also going to jump to 10 over 15. So let's see that. It goes towards 5, and when it reaches 5, it is going to jump to 1. But if you realize this one shows that it starts from 5, but they don't show you where it stops. It is just greater than or equal to 5. So it goes from 5 up to infinite. Now that infinite is shown by an arrow, so at the very end always remember to put this arrow. So this arrow is very vital because it shows that you don't know where it is ending. Therefore, that is how they draw a discrete cumulative distribution graph. So now we shall look at some parameters. One is median. Median, this is the smallest value of x for which capital Fx is greater than or equal to a half. Therefore, if m is the median, then Fm is greater than or equal to a half. We shall see how this formula is used. Then 2, we shall also see quartiles. So quartiles is divided into 2. There is lower quartile and upper quartile. So lower quartile is when Fx is greater than a quarter and noted by Q1. Then upper quartile is when Fx is greater than or equal to 3 quarters and is noted by Q3. So remember that interquartile range is the difference between upper quartile and lower quartile, and semi-interquartile range is the average. So this minus this over 2 gives you the semi-interquartile range. Another parameter is deciles. Deciles, you should remember that Fx is greater than or equal to n over 10. And percentiles, Fx is greater than or equal to n over 100. So basically those are the parameters under cumulative distribution functions. So let's see how they are used in this question. So question 10 says a discrete random variable is defined by the cumulative distribution function capital Fx. Now here we are using capital Fx equal to probability of x less or equal to x, shown in the table below. So these are the values of x and these are the values of the cumulative probabilities. Roman 1, find the median of x. Roman 2, third decile. Roman 3, 70th percentile. Roman 4, semi-interquartile range. Roman 5, expectation of the distribution. Roman 6, variance of the distribution, and Roman 7, mode of the distribution. So let's see how each of these is got. So the first thing to do is to tabulate your values. So we shall start with the values of x. Now values of x, we are going to list down all these values of x as they are. So let's come and do that. The next are the corresponding cumulative probabilities. I think you see the sign x less or equal to x to mean cumulative probabilities. So there we shall still list what was given because this is capital Fx, which means that these values are cumulative probabilities. And also if you look at this last value is 1, that is enough to make you aware that these are cumulative probabilities. So we are going to come and list all those values. Now next is to get the corresponding probabilities from the cumulative probabilities. So previously we saw how to get cumulative probabilities from discrete probabilities, but now we are given cumulative and we have to get corresponding probabilities. So that means that we keep on subtracting. Previously we were adding, now we are going to subtract. For example, we are going to come and write this very one here. Now the one here we shall get it by saying this minus this to come up with that. Then also this minus this gives you that, and this minus this gives you that, 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 and this minus this gives you that. So those are the probabilities, and when you add all of them we shall be able to get 1. Now in the question they also asked for the expected value. So we have to get the column of xpx. So xpx means that we multiply this with this to give you that, this with this to give you that, this with this to give you that, and this with this gives you that, this with this, this with this gives you that, this with this gives you that, this with this gives you that, and lastly this with this gives you that. So when I add all those, when I add all these values, I'll come up with that. Then also in the question they asked for variance, so we have to get a column of ex squared. So that one means that I say this squared multiplied by this to give you this, then this squared multiplied by this to give you that, this squared multiplied by this to give you that, it is this 3 multiplied by this to give you this, then this squared multiplied by this gives you that, then this squared multiplied by this gives you that, then this squared multiplied by this gives you that, this squared multiplied by this gives you that, and this squared multiplied by this gives you that. After that, we have to add up all these values and come up with that. So now we shall start answering our questions. The first part, they wanted the median of x. Now median, we said capital Fx is greater than or equal to a half. So what you do, you go to this column of capital Fx or cumulative and look for 0.5. If you look at this, we have exactly 0.5 here, meaning that the corresponding value of x is what becomes our median. So we shall come here and state that the median is equal to 5. So before we go to the next slide, let's see how much can be awarded for this slide. So B1 for generating these values, B1 for generating these values, and B1 for generating these values. B1 for the median. So that was part Roman 1. Roman 2, they wanted third decile. Now third decile is, remember we said decile is given by n over 10. So third decile means 3 over 10, which is 0.3. So we shall come here and look for 0.3. This one is smaller, this one is smaller, this one is smaller, but this one is bigger, meaning that 0.3 is within this. Therefore the corresponding value of x is what becomes our third decile. So we shall come here and state that the third decile is equal to 4. So that was Roman 2. Roman 3, they wanted 70th percentile. So 70th percentile is 70 over 100. So 70 over 100 is 0.7. So this one is smaller, 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 this one is smaller. But this one 0.7 is within this, meaning that the corresponding value of x is our 70th percentile. So we shall come here and state that the 70th percentile is equal to 7. Then next they wanted the semi-interquartile range. So semi-interquartile range, you have to get the lower quartile, upper quartile, and then get the semi-interquartile range. So for the lower quartile is a quarter. So a quarter is 0.25, and the good thing, we already have 0.25 here, meaning that the corresponding value of x is our lower quartile, which is 1. So we shall come here and state that the lower quartile is 3. Then next we have to get the upper quartile also. Upper quartile is 3 quarters, which is 0.75, and the good thing it is already here. Therefore the corresponding value of x is our upper quartile. Therefore we shall come here and state that the upper quartile is 7. Therefore the semi-interquartile range is given by the formula Q3 minus Q1 over 2. Therefore when I substitute and divide by 2, I'll come up with 2 as my semi-interquartile range. So before I go to the next slide, let's see how marks can be awarded for this slide. So B1 for this, B1 for this, M1 for this, and A1 for the output. So next was expectation of the distribution. So expectation is a summation of x.ex. So xpx is the summation is 5.2, and that is the value they want. So we shall just come here and state that the expectation is 5.2, which is there. Then the next part was variance of x. Variance of x is ex squared minus ex everything squared. So ex squared is this summation, which is 32.8, and ex is 5.2, which I've already seen. So we shall come here and substitute those two to get our variance. So you substitute for ex squared, which is 32.8, and ex, which is 5.2 squared. Because there is squared here, the answer will be 5.76. And lastly, they want the mode of the distribution. Mode is the value of x with the highest probability. So we shall come here in the column of probabilities and look for the highest probability. So when you look through this, you realize that this is the highest probability. Therefore the corresponding value of x becomes our mode. So you'll come here and state that the mode of x is 8. So basically that's what they wanted. Therefore B1 for getting mean, M1 for the substitution, A1 for the output, B1 for this mode. So that was discrete cumulative distribution. Now we shall go to discrete uniform, and this is the last part. Remember there were 3 parts. There was discrete probability distribution, discrete cumulative distribution, and discrete uniform distribution. So this is the last part, which is discrete uniform distribution. Just like the word uniform means, it implies uniform means constant. Therefore in this case the probability is always constant. Just as you can see here, for all the values of x, the probability is constant. That's what we call discrete uniform distribution. Now we are going to derive 2 formulas, one for getting the expected value and the other one for getting the variance. So if you start from the one for expected value is given by the formula that. Therefore I'm going to substitute for this xpx to come up with this. So this one means that, remember, this is a constant, so it can be pulled outside. That is why you see 1 over n outside, because the constant. But these values of x keep on changing, that's why they remain here. Now like I said, under standard series, this summation is equal to a half multiplied by n multiplied by n plus 1. So when I multiply this with this, we realize that this n cancels, so I remain with n over n plus 1 over 2 as the expression for mean. Now we shall go to variance. Now variance is given by the formula ex squared minus ex everything squared. But we know this now, but we don't know this yet. So we're going to first get that one, which is summation of x squared px, but I know that this px is a constant, so it comes out and remain with this there. And I know that from standard series, this summation is equal to 1 over 6n, n plus 1 to n plus 1. Therefore, this n and this n cancels to remain with that. Now that I've got ex squared, I can come and substitute in this formula to come up and then simplify. So when I simplify, I'll come up with that. First of all, n plus 1 is common. There's n plus 1 here and n plus 1 there, so it can come out. When it comes out, for this term, what will remain will be this over 6, which is there. Then for this term, there will be 1, n plus 1 has gone, so n plus 1 will remain, which is that. And this one 2 is squared, remember, so that is why there is 4 there. Then next is to get the LCM for this box bracket, which will be 12. Now 12 divided by 6 is 2, multiplied by this gives you that. Also 12 divided by 4 is 3, multiplied by this gives you that. Now when I open this bracket for the box bracket, I'll come up with this, and when I simplify, this and this gives me 1n, and this gives me negative 1. So after that, you realize that this is the difference of two squares. This and this gives a difference of two squares, which is that, and this 12 is still there. So basically that's the formula for variance. So we have derived two formulas, one for expected value and the other one for variance. So as long as you realize that it is a uniform distribution, these formulas will hold. So I'll use that formula for these questions. So question 1 says, a fair die is tossed once. Find the mean and variance, and remember to sketch the mass function. So the mean, we remember the formula. So first of all, the probability is 1 over 6 because a die has 6 faces. Therefore, now that means that our value of n is 6. Therefore, when I come here, remember the formula, that mean is n plus 1 over 2. So I substitute for n to come up with mean as 3.5. What about variance? Variance is n squared minus 1 over 12. So substitute for n to come up with variance as 35 over 12. Now the graph for a mass function is the same as the graph for a discrete PDF. So it is vertical lines. So for each it will have, remember they have the same probability. So for 1 is that, 2 it is also that, 3 is also that, 4 is also that, 5 is also that, and 6 is also that. So basically that's what they wanted. So B1 is for this PDF, M1 for this substitution, A1 for this output, M1 for this substitution, A1 is for this output, B1 for this graph. So that was question 11. Now we shall go to question 12. Say that find the mean and variance of the numbers 1 to 20 which are uniformly, this is the keyword, uniformly distributed, meaning it's a uniform distribution. Therefore we shall come and first get the PDF, which is 1 over 20 because n is 20. Then that means that the mean is given by n plus 1 over 2 to give you 1.75. Variance is n squared minus 1 over 12 to give you 33.25. So basically that's what they wanted. Therefore B1 for this PDF, M1 for the substitution, A1 for the output, M1 for the substitution, A1 for the output. So like I've already said, we are working on a project where I want to convert our hard copy books into video lessons. So this video is of Math 2 and the content has been got from this book of Mastering A-Level Mathematics Paper 2 and also from this question bank, which has topical questions of Math 1 and Math 2. I think you realize that on this platform priority is first given to UNEB questions. So these books are available in stock. If you want them, you can contact the author on this contact. Contents of Math 1 are got from this book, Math and A-Level Mathematics Paper 1, and also the question bank. I think we realized that this question bank has questions in both Paper 1 and Paper 2. Content of Physics 1 is got from this book, and Content of Physics 2 is got from that book. Content of Physics O-Level for S1 and S2 is got from there, and Content of Physics O-Level for S3 and S4 is got from there. Content of Submath is got from there, and Content of O-Level Math is got from there. So all these books are available. You can just contact the author if you want any of these books. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on binomial distribution. So if you haven't yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on binomial distribution has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.